everyone, and welcome back to my virtual laboratory. So today we're going to learn scientific notation. Let's go. How many stars do you see in the sky? There are too many, right? But do you know there is a process or a shortcut to write very large or very small number? That process is called scientific notation. Scientific notation is a way of expressing a value as the product of a number between 1 and 10 in a power of 10. For example, the speed of light is about 300 million meters per second. On the other hand, an average snail has been clocked at a speed of only 0.00086 meters per second. Instead of having to write out all the zeros in the numbers, you can use a shortcut called scientific notation. In scientific notation, numbers are represented by the product of a multiplying factor in a power of 10. Power of 10 is the number 10 raised to an integer exponent. You can write measurements using scientific notation by moving the decimal point until only one digit, which is non-zero, remains on the left. Then count the number of places the decimal point was moved and use the number of places as the exponent of 10. The sign of the exponent depends whether you count off places to the right, which is negative, or to the left, which is positive. Alright, so let's try to express this number, which is 300 million meters per second, in scientific notation. So we need to write the decimal point here, and I'm going to move this decimal point to this direction, so that is from right to left. This is right towards left. Alright, so I'm gonna move this 1, 2, 3, 4, 5, 6, 7, 8. So I'm gonna write here 3 because that is the non-zero digit, and I'm going to write the power of 10 here. How many places did I move the decimal point? That is 1, 2, 3, 4, 5, 6, 7, 8. So I'm gonna write 8 here as the exponent, and since I moved this decimal point from right to left, so the exponent should be a positive 1. So 300 million meters per second in scientific notation is 3 times 10 to the 8 meter per second. We can also express this number in scientific notation by moving the decimal point from left. This is the decimal point. This is our left side. From left, we're gonna move it towards right. Alright? And then, we're gonna count the number of places we move the decimal point. That will be 1, 2, and 3. So we're gonna stop here because these are our non-zero digits. So we need to put the decimal point in between these two non-zero digits. So I'm gonna write here 8.6 times 10. How many times did we move the decimal point? 1, 2, 3. So that's 3. But we moved the decimal point from left to right, therefore this should be negative. So 0.0086 in scientific notation is 8.6 times 10 to the negative 3.